Hello friends and welcome back. So in this session we are going to cover the Terraform architecture. In fact, in the next session as well we will extend this architecture. So these two sessions, the current session and the next sessions, are going to be very important because we are going to discuss about the building blocks of the Terraform architecture. Okay, which will give you a complete end-to-end understanding how Terraform works. Okay, and what exactly we will be doing when we are working in the Terraform. Okay, so how actually it works. So these two sessions are very important to understand. So I would recommend that do not skip a second of this particular session and the next one as well. Okay, if you really wanted to have a good understanding of the Terraform. So this is the high level architecture of Terraform. Okay, so I will come to this architecture at the end of this session. Okay, because there are multiple things are here. Okay, so if I will start discussing everything in a single slide, then you will get confused. Okay, so what I will do first, I will explain each and every component in detail. Okay, and then I will again come back to this architecture at the end of the session so that once you have a complete clarity of each and every component, right? So here you can see when that some developers or infra engineers are working in the Terraform. Okay, so they run some commands. Okay, and these commands based on some configuration files. Okay, and now after configuration file there would be a Terraform core. So this is the core heart or engine of your Terraform. Okay, and then you can see here there are some state files, and then it is talking to the multiple cloud service providers, and then we have a plugins, we have a different providers, right? So how actually it works, that means when we are working in Terraform, then what we will be doing and how the Terraform is executing our scripts or code. So Terraform architecture explain how Terraform work internally to create and manage infrastructure. Okay, so this session and the next one, okay, this will give you a complete understanding how Terraform works internally. Along with that, what we will be doing there when we are configuring the code or when we are designing the different scripts for the configuration of the resources in the cloud. Okay, so what actually happening in the background. Okay, so you will get a complete end-to-end understanding. Okay, so Terraform interact with cloud platform using a structured workflow. So what we have learned so far about the Terraform, it is a infrastructure as a code tool which we use for provisioning of the multiple infrastructure related components. Specifically we are using it for the cloud. Okay, so now suppose that this is your AWS cloud, right? And here you have a Terraform, right? So what we are doing, we are running the command from here from the Terraform. Okay, this could be on any of the virtual machines. It could be on your local system. It could be on a separate virtual machine, anywhere, wherever you want to install the Terraform, right? So once you install and configure the Terraform, right? So whenever you execute the scripts or commands here for provisioning of the resources in the AWS cloud, okay, so it follows a structured workflow. So that means there would be a certain set of steps that will be followed in the sequence. And what is the meaning of that, I will explain you in detail. Okay, so the main core component Terraform architecture includes, so what are the main core component that is participating in end-to-end execution of the Terraform code. Okay, after which your infrastructure get prepared in your cloud. The very first thing, Terraform CLI, which is the command line interface. Second is Terraform core. Third is providers. Fourth is plugins, this also called as connector. Then we have a state files in the Terraform, and then we have the resource graph. So these are the core components. Okay, you should get the understanding if you really wanted to have a good hold on the Terraform. Okay, so with going forward, when we'll go with the detailed explanation and with the execution, so everywhere you will get a deep understanding of each and every component. So what I'm doing here, because I'm going to explain the architecture, so here you will get a high level understanding of each and every component. Okay, so that you will have a good understanding when we'll go in the detailed discussion and during the executions. Okay, so by this way you will have a good foundation on the Terraform. Right. So these components work together to manage infrastructure efficiency. So it means when you are running the Terraform, okay, for provisioning of the cloud resources, infrastructure resources, so these are the different components that is participating in the Terraform executions. Right. So what is Terraform CLI? So CLI is simple. It is a command line interface, right? We have a multiple software for which we do multiple configurations from using the graphical user interface, right? And apart from that, we have the command lines as well. The many tools provide the command line tools as well for interacting with the softwares. If you do not have access of the graphical user interface, for example, what we have learned about AWS, sorry, In the AWS cloud, let me draw it here. Okay, so suppose that you have a AWS cloud account. Okay, so you have two options. The very first option, you can access the cloud management console from the browser, right? You log into the AWS console with your username and password, and from the console you can do any work in your cloud account. You can create virtual machines, you can create a storage, you can create a load balancer, you can create any other resources, whatever you want, right? So now suppose that you want to do certain kind of automation, so you can have a command line utility as well. Command line utility. So in AWS, the command line utility name is AWS. Okay, so for that you need to configure the CLI in your local system, and then whatever the work that you're doing with the help of console, you can do with the help of command line as well. But only thing is that you have to learn the syntax of command line, because this is a specific set of programming language from the AWS. Okay, with the help of that we can create all the resources, or you can say we can manage our cloud account with the help of command line as well. So we can do the automations using the scripts. Okay, so similarly, when we are working in the Terraform, okay, so what we do, we execute the different Terraform commands. So that means Terraform provide you a command line utility. Okay, it's a very small software, very simple software. You just need to download and add in your class path, not class path, exactly in the path. Okay, so that you can execute it from anywhere. Okay, and then we run the different commands with the help of Terraform CLI. And what is Terraform CLI here? Terraform CLI is simple with the name of Terraform. That means whenever you are going to execute any of the command in the Terraform, okay, you will always start with the syntax Terraform. Okay, after that we will have a different command. So here you can see we have a init, plan, apply, and destroy. So these are some standard workflows, okay, that we always follow when we are going for configuration of the different resources. Okay, so first we initialize the Terraform. There is a specific task that is done by the Terraform in the background when we initialize. Then it automatically does a planning for the resources, and then it actually apply in the cloud. Anytime you want to destroy the resources that you have created with the Terraform, for that we have a Terraform destroy. So these commands are very important, but before that we have to get the complete end-to-end understanding of the Terraform code or scripts or files that we create. Okay, so you will get a complete understanding of all these commands, okay, in the subsequent sessions with the executions, with the discussions. Okay, but here what we're discussing about is Terraform CLI. So this Terraform is a standard command, which is a command line interface we always be using whenever we are going to run any of the Terraform command. Then we have a state file. State file maintain a state file to keep track of infrastructure resources. Okay, so what exactly we have in the state file? It stores the information about resources created by the Terraform, current configuration of infrastructure, mapping between code and real infrastructure. So this helps Terraform determine what changes need to be applied. So that means whenever we are going to create any of the resources in the cloud with the help of Terraform, okay, so all the resources current state is maintained by the Terraform state file. So what does it mean? This is my AWS account. Okay, I am using the Terraform to create resources. Now suppose I run the Terraform, and that Terraform is going to create a virtual machine in the cloud. Okay, and after creating the virtual machine, it may be configuring some storage in that, and then it may be configuring some load balancer, or maybe few more, like it may be configuring a subnet. Okay, so these are some resources that has been configured with the virtual machine, your storage, your load balancer, and your subnet, right? So now when Terraform run your script, and then it is going to create these resources in the AWS cloud. So once it is created, your Terraform is going to maintain a state file. Okay, and what we have inside the state file, we have complete information about whatever the resources that has been created in the cloud. So this state file will have information about this virtual machine, this storage, this load balancer, and this particular subnet. So this state file will always have the information about these infrastructure resources. So now suppose anytime you ran your Terraform scripts again, okay, which is going to create same set of resources. Maybe mistakenly you have run the script again for which the resources already created, okay, then Terraform state will automatically identify these resources are automatically there. Okay, so your script will come out silently with saying no resource are configured, because all the resources are already there. right? So that means whatever the resources you are going to configure with the Terraform cycle, every resource state, whatever you have configured in the cloud, will be maintained in the state file. And this importance of state file we will discuss in detail when we will discuss in the next session about the what are the naming convention of the Terra file, where state file, where it is stored, and then what is the purpose or benefit of these state files. Now, Terraform core. So, Terraform core, as I said, this is the main core engine of the Terraform, which actually execute your task when we initiate the Terraform CLI. That means command line interface. So, what exactly it is doing? It is reading the configuration file. So, what we learned so far about Terraform? Terraform is infrastructure as a code. That means we maintain the infrastructure as a code. So, we define multiple configuration files. Okay, so whenever we are working on a Terraform, okay, so we define small multiple configuration file, and these configuration file contain information about the resources that we are going to configure in the cloud. Now, suppose that this is the first file, 1.txt. I'm just giving example. Okay, we do not store with the extension of .txt. Okay, I will explain you what is the extension that we use in the Terraform. Okay, so this file contain about VPC. We have to create a VPC. Second file contain information about subnet. After creating the subnet, sorry, VPC, we need to create the subnet. So once the subnet is created, third file is to create an EC2 virtual machine in AWS cloud. Okay, so these are the certain resources, okay, like VPC, subnet, EC2 virtual machine. So we have a different configuration files, okay, which contain the standard syntax of each and every component that we are going to configure, right? So when we run the Terraform command or Terraform CLI, it reads the configuration file that we have created. It understands the desired infrastructure state. So what would be the state of infrastructure? That means here is the command to create a virtual VPC. It will check whether this VPC is there or not. If it is there, already there, this VPC with the same name, okay, then it is not required to create, and your configuration or your Terraform will skip this VPC because this is already there. Okay, so that means it understands the desired state. If this need to create or this need to skip because it is already there, then it create an execution plan. So that means once your Terraform completely understand out of all the resources, what all resources are already there, what all the resources I need to create, okay, it create a plan file. So this is a plan file. Okay, again we are going to discuss in detail in the next session. So it will create a plan file. So this plan file will have all the information about execution. You can say this is a pre-execution file which will tell you about what exactly it is going to do when you are going to execute the execution. Okay, so this plan file will contain the information like, okay, this is a VPC, this is already there, so I am going to skip this one. This subnet is not there, okay, so I will create this one. This EC2 machine is not there, so okay, I will create this. So it will create a plan file which you can review anytime before doing the executions. Okay, and once the execution is done, and when you actually execute this particular plan, okay, then the resources will be get created in your AWS account or any of the cloud CSP, whatever that you are using, and then the state of each and every component that has been configured will be maintained in the state file. So this is the high level workflow of how the execution work with the help of Terraform core, and we'll discuss in detail in the next subsequent sessions with the theory as well as with the lab exercises. Now Terraform configuration file. So what we have learned so far in Terraform, we whatever the resources that we want to configure, we first create the different scripts or small script, which is also called the configuration files. Okay, so that means Terraform is a configuration file based tool. Whatever the resources that you want to configure, for that we have to create the different configuration files. Okay, and we are going to learn this in detail, how we create the configuration file, what are the different configuration files, what is the syntax of that, how we create that one, everything you will understand detail in this course. Okay, so these configuration files contain the information about the infrastructure, whatever we want to configure, right? So whenever we create these configuration files, okay, so we store this file with the extension of .tf, Terraform files. Okay, so this is the main infrastructure configuration files, right? Now second type of files we have, which is the extension of .tf var, Terraform variables. So this file contain the variables. So now what does it mean, variable here is? So as I explained earlier, in Terraform we apply the object oriented programming approach. That means define once and use multiple, right? So that means, uh, suppose you want to configure your production environment, you want to configure your development environment, you want to configure your testing environment, quality environment, non-production environment, which is called the pre-prod environment. So suppose you want to configure the multiple environment. So you will have a separate VPC for each and every environment. You will have a separate subnet for each and every environment. You will have a separate virtual machine for each and every environment. So you will have a different resources in each and every environment, right? So what you can do, we can create a generic configuration files, or you can say the single code file. Okay, and then what we can do, we can provide the variables to this particular configuration file, right? So what will happen in that case? Reusability. Our configuration files will be designed only once. Same configuration file will be called for each and every environment. Okay, and only a difference that we have a variable file which contain the name of the variable which we are going to pass to this particular configuration file. For example, the VPC name is VPC underscore prod for my production. For development, my VPC name will be VPC underscore dev. For testing, my VPC name VPC underscore test. So what I will do in configuration file, when it is a production implementation, I will specify this particular VPC name. If it is a development implementation, I will specify this VPC name. If it is testing environment, then I will specify this VPC name. So I just need to define variable file, and then this variable will be input to your configuration file. So we have a standard configuration files, right? So this is the variable files, and the files managed by Terraform. So as I said, there is a state file which maintain the complete end-to-end state of the resources that has been configured in the cloud. Okay, so the state file will be extension of .tf state. So you will see a file with the extension .tf state. Okay, this is containing the main infrastructure file, which is having the complete information about all the resources that you have configured with the help of Terraform. So it is very important to maintain the proper backup of this file, because this file has the end-to-end information about your infrastructure. Okay, so automatically your Terraform create a backup file for this TF state. And apart from that, you will have a log file as well, which provide the version log. So you don't need to worry about this particular file. It is automatically created. Even in fact, all three files are automatically created. Okay. You only need to make sure that you have a proper backup of all these files always. Now providers. So providers is very simple. Okay. So as I said, your Terraform is a cloud agnostic. That means your Terraform can be used to implement the resources in the multiple cloud service providers. So CSP, cloud service provider, here is referred as the providers. That means providers allow Terraform to interact with the different platform and services. Each provider connect Terraform to a specific platform. So these are the different providers. Like you are working with the AWS, Azure, Google Cloud, IBM, Oracle Cloud, maybe Kubernetes Cloud. So providers translate Terraform instruction into API calls for the cloud platform. So now what does it mean? I will explain in the next few slides. Okay. So here what exactly we are talking about is, you have a Terraform, and with the help of Terraform, you can configure the resources of the multiple cloud service providers. So this is the providers. Now plugins. So plugin, we have discussed few things about these plugins also some time back as well in the previous sessions. So plugins, which is also called connectors. And what is the use of connector? Is very simple. We have a Terraform that we have configured in one of the server, maybe in our local machine or maybe in some remote virtual machine. And from here, I am executing the different Terraform commands to create the resources in my AWS cloud. Right. So this Terraform is going to connect to the AWS cloud. So maybe you are using the Azure cloud, or maybe you are using the Google cloud, GCP, or it could be your IBM cloud, or it could be your Oracle cloud. So your Terraform is need to connect to each and every cloud service providers, right? So what is the way how your Terraform can connect to the different cloud service providers with the help of plugins, or which is also called the connector. So here you will have a connector for each and every provider. Suppose that this is a connector C1 for AWS, there is a connector C2 for Azure, there is a connector C3 for the Google, there is a connector C4 for the IBM cloud. Similarly, you will have a C5 connector for the Oracle cloud. So there would be a connectors. So these connectors allow the connectivity with the different cloud service providers. Okay. Again, you don't need to worry about the connectors. So when we initialize the Terraform, okay, initially when we configure the Terraform, that we have to initialize it. So when we initialize the Terraform, so these connector will automatically get downloaded. Okay, so this will be covered in detail during the executions as well, right? Then resource graph. So what is resource graph? Again, it is a very simple concept. Terraform build a resource graph to understand relationship between resources. The resources graph define dependencies between infrastructure component. So what is example? Let me first explain you example and then I will come to the definition. So here you can see, suppose that what we are going to do, we are going some resources in the cloud with the help of Terraform. So their EC2 instance depend on VPC. So if you have a good knowledge of cloud or if you have gone through the initial sessions of AWS, so what I told initially, whenever we are working on the cloud, okay, so the very first thing in the AWS, okay, first what we create the VPC, which is your virtual private cloud. So each and every customer will get their own virtual private cloud. Okay, so that they have a isolation from the other customers in the same cloud data center, right? So that means very first thing we create the VPC. So now if you are going to create the EC2 instance, a virtual machine in your cloud, so before that you should have a VPC in place, right? So that means your EC2 instance depend on the VPC, and along with that, when we create the EC2 machine, we need to attach the EC2 machine with a subnet, right? It could be a public subnet, it could be a private subnet. Okay, so that means whenever we are going to create an EC2 instance, there are two dependencies. We should have a VPC in place. We should have a subnet in place. So once we have these two components are in place, VPC and subnet, that only you can able to create the EC2. So that means if you are going to create the EC2 machine, your Terraform understand the dependencies. Okay, that means when you are going to create the EC2 machine, your Terraform will expect a VPC in place. It will expect a subnet is in place. So this is called the resource graph, or you can say the relationship between the resources. So resources EC2 machine, VPC subnet, and what is the dependency here, or what is the relation here between the resources? EC2 machine should depend on VPC and subnet. So Terraform use this graph to create resources in the correct order. So your Terraform should understand all this relationship between your component. Why? To create the resources in the correct order. So that means dependency graph concept. So Terraform automatically identify dependencies between resources. So if an EC2 instance required a VPC, Terraform will create a VPC first, then create the EC2 instance. So this dependency graph ensure infrastructure is created in the correct sequence. Okay, and this is also referred as your workflow, right? That means first create VPC, then create subnet, then create virtual machine, and then some other dependent resources. So everything is getting executed in the proper workflow wherever you have a certain dependencies, right? Now APIs in the Terraform. So API is a very critical component, okay, from the understanding perspective, how Terraform works. Okay, because what we have done so far, we have a plugins or connectors. Our Terraform connect with the different cloud service providers with the help of connectors, which is also called the plugins. Okay, but the plugin is used to connect to the CSP. Okay, but to create the resources inside the cloud, we need the APIs which is exposed by certain cloud service providers. What does it mean? This is AWS, this is Azure, this is Google Cloud. Now suppose here I have a Terraform, right? Now here I will have a plugin or connector for each and every cloud service provider. Connector 1 for AWS, connector 2 for Azure, connector 3 for Google. So this connector is helping me to connect with the different cloud service providers. But when I connected, after that I need to create the resources, right? Everywhere I need to create the resources. For example, virtual machine, storage, load balancer, anything. Okay, so to create the resources, each and every cloud service provider has to expose the APIs, application programming interface, for which allow you to create the actual resources inside the cloud service providers. So if you are not clear on APIs, so API is called the application programming interface. It is a way to one software to communicate with the other software. It act like a messenger between systems. You send a request, API process it and return the response. So that means every cloud service provider will expose the APIs. Okay, your Terraform will use the connector to connect with the cloud service providers. Once connected, it is going to use the API of that particular cloud service provider to create the actual resources inside your cloud account. Right? So Terraform interact with cloud providers with the help of APIs. Okay, and once the API call is success, then it actually create the resources inside the cloud, and the response sent back to the Terraform. Okay, the resources has been created, and then it will be stored in the Terraform state files. So how Terraform work internally? Now the workflow is very simple to understand. User configurations. So first we create our different configuration files in the Terraform. Then we have a Terraform command line interface. We run that CLI, some different CLI commands, Terraform commands. It is executed by a Terraform core. Then it come in the picture. We have provider plugins or the connectors which we use to connect with the different cloud service providers. And then with the help of APIs which is exposed by the different cloud service providers, the resources will get created with the help of Terraform. So Terraform read configuration files. So what we do, we create all these configuration files based on the resources that we want to configure. Then Terraform process them and communicate with the cloud service platforms with the help of APIs, and then actually execute the request. Right. So now this architecture will very clear to you. Here you have a DevOps engineer. So engineer is writing the different Terraform files. The Terraform files will the extension .tf. Okay, if we are using the variables, then we have a tf-var files as well, right? And then we run the different Terraform commands like the Terraform plan, Terraform apply. And when we run the command after the configuration of configuration files, your Terraform core engine is going to take the request and executing the request. Okay, and then it connect with the different cloud service providers, and the state of your infrastructure is stored in the Terraform state files, which is the extension .tf states. So Terraform can connect to the multiple providers. We have a different kind of a provisioner, so that I will explain you in the during the execution what is the meaning of this provisioners. Okay, and then we have a connectors there. So these connectors help to connect to the different cloud service providers. So this is the high level architecture of your Terraform, and in next session again we are going to cover the multiple core functioning in detail, and that is going to be another critical session after this particular.